The other main thing that I wanted to talk about with you guys today is your parent function. I'm sure you've heard reference to it a couple times. If you're in my class, I know you have because I've mentioned it. If you're in Mr. Serene's class, I bet it's come up a couple times. But there's these things called parent functions. And parent functions are this concept that it is the original function that was of this variety. And so here is your parent quadratic. I'm going to call this of the quadratic variety. Here is your parent quadratic function, and it will always be that. This is always the parent function for quadratics. For all quadratics, this was the original quadratic function versus the original cubic function. The parent for a cubic function would be just x cubed. The parent function for a square root function is just the square root of x. But we know that they could become like x cubed minus 5, or they could be the square root of x plus 3. So they can be all sorts of transformations from our parent function, but we always start with the most bare minimal version of that type of equation. And so the bare minimal version of a quadratic equation is just x squared. Anything else is a transformation from our parent function. All other quadratics are transformations from a parent function. And transformations. And they typically follow they always follow this rule. Since this is called f of x, I'm going to call my transformed version g of x. That there's these things, these series of things that you could do to your parent function. You could have numbers being added or subtracted within the squared. There could be a number in front of the parentheses. You could have a number being added or subtracted outside of the parentheses, and all of these have some sort of indication of the transformation that happened. This is also called our vertex form, as we've definitely talked about in the past. It's called the vertex form because our vertex is found oh so easily in this form. Our vertex is your h value and your k value. H for horizontal, k for vertical movement. So here is your vertex. I want you to notice one very important thing, that your formula requires it to be a subtraction here, which means that when you're finding the x value of your vertex, you need to keep in mind that the vertex form is saying x minus h, which means really what you plugged in here for your vertex form is a -2, such that it resulted in addition. If the original form called for a subtraction, if you see that there's a plus here, that means that you plugged in -2 for h, such that it resulted in +2, which means that the vertex, the x value for the vertex of your parabola would be -2 here, not +2. So you can see how that might be confusing. So just be aware of that. That's the most tricky part of this. Really what it means is that your h is your horizontal shift, right? We've moved our vertex from 0, 0 in a horizontal way, in some way, shape, or form. We've also moved all of our y values in a vertical way. So we've moved our origin up or down for our vertical movement for our vertex. And we've also moved it side to side. And then a is the stretchiness of the is that how you spell it? I don't know. But that is the stretchiness of your parabola. That's about like how stretched out, how skinny is the parabola? Did we pull up the parabola really, really tall and skinny, or did we kind of flatten it out and squish it and make it like a really fat parabola? And so A tells us that. So you can talk a lot about the transformations as well as you can determine what's going on with the vertex. We can even graph from vertex form. I would like for you to also notice that vertex form is completing the square. This is why we learned about completing the square. This is why completing the square is so important, because putting it into vertex form can tell us a lot about the parabola, not just the vertex, but how stretchy it is, whether it's going to be fat or thinner, a lot of different things. So completing the square gets us to this form. It's why we learned about it. This is our vertex form. Let's practice. We're going to sketch a graph of the function. You should always have like a ruler and a pen with you when you're talking about graphing, so then that way we can draw in things like our axes without having to worry about erasing stuff. So I went ahead and put in my axes here. And I want to show you how graphing your equation using your vertex form in terms of transformations, how it can be helpful. So with our parent function, x, y, we could do -2, -1, 0, 1, 2. And our y value then becomes -2 squared is 4, 1, 0, 1. So I just went ahead and found points from our parent function, right? I just did -2, -1, 0, 1, 2, which are normal inputs for x values when we're trying to graph something. Here are the outputs by just plugging in these values into our parent function. So then y, which is this function right here, follows along a certain set of rules, that it's being shifted not right because it's inside of the parent function, it's inside of that squared piece. So since it's supposed to be a minus here, it's shifted left 2 and down 3. So that's true about our vertex. Our vertex is at -2, -3. But that's also true about all of our other points. So not only is our vertex 0, 0 now -2, -3, I can now also take -1 and shift it left 2, which means -1 minus 2 would be -3. -2 minus 2 would be -4, -1, 0. And then taking all my y values and subtracting 3, because I shifted all of my points down 3. So I could do 4 minus 3, 1 minus 3. 1 minus 3, 4 minus 3. And those are now all of my new points. So I can take all of my new points and plot them. -4, 1. -3, -2. -2, -3, -1, -2, 0, 1. And then you'll have these numbers pretty straightforward and pretty memorized. I mean, they're not that difficult. And so when you start to see functions like this, you can be like, oh, well, I just take my 0, 0 and put it left 2, down 3. And then I could take my 1, 1 and my -1, 1, which are represented here and also here, and then do those same transformations. Right? So you would go through and just do those transformations. It could be like a really quick shortcut if you understand the relationship of parent functions to the transformations that happen. I would like for you to go ahead and take a look at this function, and I would like for you to tell me about all of the transformations that have happened in this function. So looking outside of the parent function, the only thing we have outside of the parent function is your -5. That means it's a vertical shift of down 5. And then this -3, so it's happening inside of the parent function, so it's the opposite of what you think it is. So -3 is actually thinking of, we plugged in a +3 for the h value up here. So with a +3 for the h value up here, that means that our horizontal shift is right 3. Even though it says -3 here, we're going to do the opposite of it because the formula calls for it. So if we're going to go right 3 and down 5, I want my axes to be here and probably something like here. So then my 0, 0, my vertex of the parent function would go down 5. right 3. My 1, 1 would go down 5, right 3. You can also repeat what you know about parabolas, that you would go right 1, up 1. You would also go back 1, up 1. That would be your negative 1, 1. That would go down 5, right 3. You also know that you would have 2, 4, which would go down 5, right 3. You also know that you would have negative 2, 4, which would be down 5, right 3. So it can be really quick. So this is a shortcut that a lot of math teachers use of understanding, hey, these are all just transformations. This is what the transformation is. So I can just plot enough points for me to know what's going on with this parabola. Again, this was all really fast today. Hopefully you kept along. If not, definitely feel free to ask questions the next time you see either me or Mr. Serene, or you've got all of these videos that are already talking about this. So hopefully this is old news and you feel really confident. If not, you know what to do.